which is on molecular formula and empirical formulas. Empirical formulas are the lowest ratio of atoms in a compound. Up till now, have you been familiar with molecular formulas, which are the actual or the true formulas that we have worked in the previous sections to come up with? If we write a formula, then that represents the lowest, the true number of atoms in a formula. However, if you take a compound and you look at the ratio of the number of atoms, and this ratio is generally taken as a whole number, then you can represent that as an empirical formula. So, for instance, up here, if we look at the molecule that is shown to you up here, which this molecule is a whole number. Let me just get my pen tool up here. Yes. So we've got a molecule that is 7-to-C5H10O5, and that molecule, we want to see what would be the actual ratio of each atom in there. So you would take the number, you would take the total, the simplest whole number of the atoms you have taken. So notice you divide that 10 plus 5 plus 20. So you've got 20 and divide that by 5, and now you will come up with the ratio. But since 5 is the lowest number, divide all of them with 5, and you see that the ratio of carbon is 1, hydrogen is 2, and 1 is the ratio of oxygen. So this is considered to be an empirical formula, which is the simplest whole number ratio of the atoms. Again, the empirical formula is not the true molecular formula. This would be your molecular formula. So let me give you another example. So what about the molecular formula for glucose? If you have C6H12O6, what would be the ratio of each? So now since we have 6, I'm going to divide all sides by 6, and you will see the ratio would be 1 carbon, 2 hydrogens, and 1 oxygen. This would be the empirical formula for glucose. Sometimes the molecular formulas and empirical formulas are the same, and sometimes they're not. So here are some examples. You can see for ammonia, the molecular formula is the same, but not for all of the others. The others, you will have the lowest ratio of them. So a simple guide to calculating empirical formula is first calculate the moles of each element that are present, shown to you on a formula. Divide by the smallest number of moles to make it easier, to make it an even or an odd number. And then use the lowest whole number ratio to represent that subscript. Now let's look at a problem and try to solve this. A compound contains 7.31 grams of nickel and 20 grams of bromine. What would be the simplest empirical formula? Now, in order to do that, we would have to first convert the grams of nickel into moles of nickel, because you can't take grams in an empirical formula calculations. So notice up here, we set the conversion of grams to mole by what we learned in the previous section. One mole of nickel equals approximately 59 grams of nickel from the periodic table. So 7.31 grams of nickel will yield 0.125 moles of nickel. And 20 grams of bromine is also set up in the same pattern. 1 mole of bromine from the periodic table you can see is 79.90 grams of bromine. So 20 grams of bromine will be set up the same way, and that yields 0.25 moles of bromine. Now this would be my first step. Again, if you are given in grams, you have to convert that into moles. The second part would be to now divide that by the lowest of the two. So 0.125 is the lower value, so I divide both of them by the lower value. So notice up here, I'm dividing this by the lower value. That will give me 1:2. Once you have the moles of nickel, then you can use the lowest whole number to represent that as a subscript. So the subscript of nickel, since we had 1 for nickel, so we left it at Ni, and Br would be 2. Another section we want to go over is to how do we relate molecular and empirical formulas to each other. A molecular formula is always equal to or multiple of its empirical formula, because remember, in a molecular formula you take the actual number of moles of an atom and you add you take the mass of all of them. Now, however, if you take the molar mass and you divide that by the empirical mass, you get a small integer. And by multiplying the subscript with in the empirical formula by the same integer, you will get the molecular formula. So let's see over here a relationship between all of these: molecular formula, empirical formula. Divide that, you will get a small integer. Then use that integer to calculate the molecular formula. Here is just a table from your book that represents some empirical formulas and some molecular formulas. So you can see for acetaldehyde, the molecular formula and the empirical formula is the same. For acetic acid, notice the empirical formula is different than the molecular formula, because in the molecular formula, we can reduce that by a fraction of 2. Same thing for lactic acid, same thing for erythrose and for ribose. Each of them, so an empirical formula generally is giving you the ratio of elements present in that compound. Now let's look at a problem done in which we find the molecular weight of a molecular formula. So in this problem it says determine the molecular formula of a compound that has a molar mass of 78.11 gram and an empirical formula of CH. So since we know the empirical formula, which is the ratio of the two elements, we also know the molar mass. We will now go ahead and calculate its molecular formula. For step 1 would be calculate the empirical formula mass. So the formula mass would be the molecular weight of carbon plus hydrogen. That gives you 13 grams. Step 2 would be divide the molar mass by the empirical formula to get a smallest integer. So when you divide that, whatever value you come, use a whole number for that. So this is, you've taken 78 grams of the molar mass divided by the empirical formula, you get a value of 6. In step 3, you will multiply the empirical formula by the small integer that we just earned. So the empirical formula was given to us was CH. So you will take CH and you will multiply that by the lower whole number, that is 6. So the formula would then be C6H6. We'll probably do some more problems in class to reinforce these concepts. Here is another example. A compound contains 24.27% of carbon, 4.07% of hydrogen, and 71.65% of chlorine. The molar mass is about 99. What are the empirical and molecular formulas? Now notice in this one, what we are given is the molar mass, and we are given percentages. So based on the percentages, we have to determine the empirical and molecular formula. So the first step, whenever you have percentages, you want to convert that using the expression of moles. So notice we have 24.27% of carbon, which means that we want to see what is the total moles of that. So 24.27 grams of carbon is 2.02 moles of carbon. Same thing, 4.07% expressed in grams is 4.04 moles, and 75.165 chlorine is 2.02 moles. So once we have the moles, we will now divide that by the lowest of the moles. And the lowest in this combination is 2.02 is the lowest. So we divide each of them by 2.02, and we get 1 mole of carbon, 2 moles of hydrogen, and 1 mole of protein. So this would be the empirical formula, which would be C1H2 chlorine 1. And in this case, now once we have the empirical formula, we are now calculating the empirical formula mass, which is 49.48. So this is the empirical formula mass. We still have to find the molecular formula for this problem. So this problem is not completed here. So once we have our molar mass, the molar mass which was given to us, let's go back over here, was given to us already, was 99 grams. So we take the 99 grams that was given to us, and the empirical formula we calculated was 49. You divide that, you get a smaller integer, which is 2. Now you take the small integer and multiply that to the empirical formula to come up with the true molecular formula of this compound. So these were some problems on this section on chemical quantities. Most likely we'll be doing a couple of these problems in class as well, and I'll probably reinforce these concepts better. Here is a concept map for you to look at. This concept map is very nice because it gives you a relationship between all units that we were talking about. So we have atoms. Atoms have an atomic mass, which is determined by the periodic table. Atomic mass is then used to calculate molar mass in grams. Molar mass can be converted into moles in grams and grams to moles. Now for moles, remember moles contain an Avogadro's number of quantity, but they also have a molar mass. The molar mass is going to be calculated back from this section. So you use that to calculate the molar mass. In a percentage composition, you just use that to express an empirical formula, and then you can use that to find molecular formula. This section is the most important section that you need to understand is molar mass, how to convert moles to grams, and how to do grams to moles. So this concludes your lectures on this section, and we will review more of these problems in your quizzes and in your class handouts.